GETEM webinar. My name is Matt Perliman. I'm a developer and researcher on the System Advisor Model team here at NREL. Today, I'll be giving a webinar on the GETEM model in the System Advisor model, or the Geothermal Electricity Technology Evaluation model in the System Advisor model. Agenda for today. First, I'll be giving an introduction, and for those who aren't familiar, into what the System Advisor model, or SAM, is. An idea of what the user base for SAM is, and some advanced features that make SAM such a useful tool for evaluating renewable energy projects. And then I'll get into an introduction of the GETEM model and how to use GETEM in SAM in our slideshow presentation before going into a live demonstration of our SAM software and some of the key inputs and outputs of that model, while saving plenty of time at the end for Q&A and discussion. The quick housekeeping: question and answers will be handled through the questions box in GoToWebinar. So depending on whether you're using the online viewer or the desktop application, it may look a little different, but you can enter questions in the questions box on either, and somebody from the team, from our NREL SAM team or from our geothermal team, will be able to answer that question in the chat, or they will mark it to be answered live during the webinar. And we'll also leave time at the end for some more open Q&A discussion. Also, this webinar is being recorded, and the recording will be made available following this webinar at the SAM website and on the SAM YouTube channel. So now getting into the meat of our presentation, the System Advisor model is a free software tool that allows for detailed performance and financial analysis for renewable energy systems. It primarily exists as a desktop application that can be downloaded on Windows, Mac, or Linux. It is also, for PV-focused users, a PV Watts web tool and API. The SAM code also exists in different forms, such as a software development kit that's useful for bringing the SAM code into your projects, a unique PySAM package to be able to bring the SAM models into Python. All the SAM code is open source and available for viewing on GitHub. There's extensive help documentation and user support for SAM as well, found at the website sam.nrel.gov. A quick overview of how SAM works, basically. First, you start with your performance model. Today, we'll be focusing on geothermal power, particularly in the GETEM model, to calculate hourly, or in the GETEM model case, monthly power production values based on specifications for your geothermal power system and any losses that you might incur, to get monthly, annual, hourly energy outputs and important metrics such as the capacity factor. You bring those production outputs and combine them with details such as project cost, incentives such as the investment tax credit, financing considerations such as debt terms, and revenue or compensation, such as what your PPA price would be for a plant, to get important financial outputs such as your net present value, levelized cost of energy, payback period, operating costs, revenue outputs, and detailed cash flows that you can see all in the SAM outputs. The SAM model covers a variety of technologies and financial structures. You can see everywhere from photovoltaic down to biomass. Today we'll be focusing on geothermal power. And that geothermal power model can be used with a variety of financial models, focused primarily on large-scale systems that have power purchase agreements, such as a single owner or various partnership flip structures. The history of SAM, the original vision for it was in 2004. SAM was developed by DOE, us here at NREL, and San Diego National Laboratories, and developed to be able to model these renewable energy systems with also detailed financial analysis. And since then, it's grown a lot. The SAM users, we like to present these stats to people to kind of give an idea of SAM's reach internationally. So we always used to say that SAM is started once every 2 minutes. And as of a couple weeks ago, we ran those numbers, and it's actually being used even more. So SAM is started once every 1.4 minutes. We have over 150,000 users in 190 plus countries. Our webinars have over 280,000 views, the recordings. And you can see we've worked with a variety of external partners such as Sunrun, Enphase, Southern Company. A lot of those focus towards PV, but we do partner with industry on a variety of different technologies and projects. What are the types of SAM use cases and who's using SAM for what purposes? Utilities and lawmakers want to study policy changes and how that can affect the techno-economics. Engineers and developers want to look at different sites, configurations, do some comparisons, and look at LCOE numbers from different system designs. Researchers are looking at new concepts for technologies and how that can improve energy performance and subsequently LCOE, and look at technical potential. And then this is also very popular with students to just learn about different renewable energy technologies and how they work and get a better idea of what the financial implications of those projects might be. So as we mentioned, SAM has a lot of use cases within NREL and outside of NREL. So just a kind of a graphic here, give you an idea. The red squares at the top show that SAM is being used by external system engineers and installers all over the world for different types of technologies. And then internal to NREL, SAM is very useful as it's used as a base for a variety of different technologies or software models such as DGen, Reads, and Plexos. And then those are used to help develop larger studies such as the GeoVision study, standard scenarios, other types of big, large-scale studies of future performance. There are a variety of ways to access the SAM models. The most basic one that we'll go over today is a desktop application. Within that desktop application, there's some advanced analysis tools such as parametric analysis, stochastic analysis, and within that stochastic analysis, probability of exceedance, such as your P50, P90 energy predictions. There's a built-in scripting language to extend your analysis beyond what's within the models of SAM within the desktop tool, such as external macros that can extend your analysis further. The software development kit helps to bring the SAM code into your programming language of choice. The most popular one, of course, is our PySAM package to bring the SAM code into your Python notebooks or scripts. And as I mentioned, all of the SAM code is open source. So I'm not going to spend too much time on these, as I just mentioned, the scripting language to extend your SAM analysis further by using a built-in language to do further analysis from your SAM cases or write your own macros. Parametric analysis, you can vary your inputs over a range of values and evaluate the change in output on energy output or financial outputs. Or you can vary your inputs stochastically and get an idea of your probability of exceedance for your annual energy output that way. SAM is pretty unique in that it has the detailed performance calculations for a variety of different renewable projects with the detailed cash flow and time-based financial modeling across different market sectors. So depending on technology, you can look at front of the meter, behind the meter, market evaluations, and financial structures. All the source code is available on GitHub, so you can see what our models are actually calculating and how we're getting to those results. And SAM has extensive help documentation. sam.nrel.gov has a lot of resources for getting started on any type of project. The YouTube channel has all of our old webinars that can help you start on your project or get familiar with SAM. We have monthly roundtables where you can ask questions live to the SAM team and get support that way. You can get email support. That email is sam.support@nrel.gov. And there's the user support form on the website that is checked daily for issues that come up that you can submit to for help with your projects. So with that, I'll shift gears a bit to talk about the GETEM model. So as I mentioned previously, GETEM is short for the Geothermal Electricity Technology Evaluation Model. This combines calculations of geothermal power calculations for both hydrothermal and EGS resource and allows for either flash plants or binary plants to be calculated. to get performance outputs that can then be used to calculate levelized cost of energy, or LCOE. This has primarily existed in Excel for several years, and it was originally developed by Greg Mines at INL. There has been a version of GETEM in the SAM model for several years now. In the last 2 years, we've made big efforts to align the GETEM model, the most recent version of the GETEM Excel model, with the SAM model, and make SAM the place to go to for your GETEM analysis. So that work has included updates to the pump work calculations, new features such as that I'll get to in our live demo, such as the user-defined reservoir model, and calculations of temperature loss in the production well. Didn't quite come through on the slides here, but we did do a couple validation cases for like default project sizes and for EGS binary and hydrothermal flash plants. And the energy output results were matched pretty much one-to-one with the results from GETEM Excel by the end of these updating efforts. So we feel confident about the results matching from SAM to Excel, and that SAM can be trusted for its outputs. There are plans for a few more sensitivity analyses to further those validation efforts to check with the SAM implementation. So a quick look into some of the inputs for the SAM model before we get into the live demo. We start with defining a geothermal resource. So on this page, you would define whether you have a hydrothermal or EGS project. You would define your key parameters for your resource temperature and your resource depth. And then you would calculate your reservoir model. There's now 4 different ways to do that in SAM. There's a pressure change, single input, EGS, Green Garden-based fracture modeling, permeability calculations, or a new user-defined table of reservoir performance over time as an option. And new to this version of SAM, there's also the ability to load in default base cases from the GETEM Excel model that will update some of your inputs in SAM with cases from the GETEM model. Next, you can define your plant. You can specify either by the kilowatt output you want for your plant or the exact number of wells that you have. You can specify whether you have a binary or flash plant and the efficiencies that come with that. You can either specify a constant temperature loss in your production well or use the Ramey model calculations to calculate the temperature loss in the production well. And then you can specify your temperature decline for your resource over time, and as well as your pumping requirements, such as your well flow rate, pump efficiencies, casing diameters, and the like, to figure out your pump work required for your project. Once you define your system, you have to define the cost of it. A key thing here is the production and injection drilling cost curves. These cost curves come from the well cost simplified model developed by Sandia for different cases where there are 4 different cost curves for each combination of well type and well diameter that come from the GeoVision report. So we have that implemented in SAM along with a visual representation of where you fall along that cost curve. And then a benefit of SAM is SAM has a variety of different output metrics, both on the performance energy side and on the financial side. So a quick look at a couple of graphical outputs that come from SAM for monthly energy output, net generation year over year, and resource temperature over the life of the system. And then also financial outputs, we have detailed cash flows, annual cash flows with different cost metrics there. And then in addition to key financial metrics such as LCOE, net present value, internal rate of return, those kind of metrics presented in tabular data that can be exported and then used for your analysis. And some of this will be easier to see when we jump next into the SAM demo. I wanted to check if we have any outstanding questions at this point that you think should be addressed before we move on, Paul.
Yeah, Matt, there's a question. that maybe you can address when you're doing the demo, which is the plant output a mandatory output? Maybe is the plant output a mandatory input? But question about the plant output parameter.
Right. So I would say to that, we can get into it more in the demo, but if you don't know your specific plant output, then you can specify it by the number of wells you have. And based on the efficiency of your plant, and that will calculate what the output is if you don't know it exactly. So you can specify by number of wells or by specific plant output.
Okay,
and with that, I will.
There's another question here,
Yep.
which is, does this have the same restrictions as Excel GETEM regarding binary cycle plants above 200 degrees C?
That's a good question. I would have to double check to see if it. I don't think it's strictly enforced. Like the SAM results will run even if those boundaries are not met, but the results you might want to. I think those restrictions are there for a reason a lot of the times. Maybe Dio could chime in, but I think it'll let you run the results, but the outputs you might have to check for accuracy.
Yes, you can actually run binary above 200 as well on SAM. But the flash calculations, yeah, you would have to, like Matt is emphasizing, especially as you get towards 150, you might have to recheck the results.
Okay, so with that, Paul, is there anything else?
No, go ahead.
Okay, and we are seeing the SAM splash screen, correct?
Yes, yep.
Okay, so with that, we'll start our live demo of the SAM model. So when you download SAM from the website and first launch a desktop tool, you will get to this screen. There's usually a welcome message. If you open SAM today, you'll see a message reminding you to join today's webinar. So thank you for joining, all of you that are here. You'll see also a list of recent files you've opened, and your menu will start here where you can start a new project. You first start by picking a technology, so we will pick geothermal, and then you follow by picking a financial structure. So we're going to focus on the simplest one today, a power purchase agreement with a single owner financial structure. This loads in a variety of pages that starts with defining your system and then proceeds into defining your cost, your financial structure, your revenue situation, incentives, depreciation, and flows in that order from performance to financials. So the first page, you see this ambient conditions tab. This is just a way to get data for ambient dry bulb temperature that currently is not used in the GETEM model. There are plans to incorporate it in the future, but for now, this is just an option that occurs with when using a model different from the GETEM model, which I'll touch on briefly. It's not really key to today's talk because we're going to focus on the GETEM model. But so basically, for now, for the GETEM model, you don't need to focus on this ambient conditions tab. So we can skip over to geothermal resource, where, as I showed you on the slides, we start with our resource characterization by defining if we have a hydrothermal plant or an EGS plant. We can define our total resource potential, which determines how many replacements you can make within the lifetime of the plant, resource temperature and resource depth. And then your reservoir parameters are defined in a variety, depending on your selection, different ways. There is a single value for a pressure change across the reservoir, which is a simple single input that's calculated. When you have an EGS system, you can use simple fracture flow, grid garden-based calculations to calculate the reservoir performance. You can use a permeability model to calculate the reservoir performance. Or new to this version of SAM, when you are using an EGS system And you can click this fourth option to get a user-entered reservoir model, where you can import a table from a CSV file of the time, temperature, and pressure for the reservoir. So as the time of the system lifetime increases, what is your temperature and what is your pressure? This is a new feature, so we welcome a lot of feedback on how this can be most useful to users and what format this should take. Ideally, something that can be in a simple CSV file so that we can kind of allow for inputs from a variety of different reservoir modeling tools, external tools. But we do welcome feedback on that. Moving over to the plant and equipment. So our question earlier, if you know your plant out, if you know what you want your plant output to be, you can specify that, or you can say, I want exactly 3 wells, and that'll be calculated your output from there. You can specify a binary plant with a plant efficiency, or a flash plant where you can have single or dual flash. Your plant design temperature is carried over from the previous tab. For those unfamiliar with SAM, white boxes are inputs that the user has to provide, and blue boxes are values that are calculated based on the white boxes and other inputs. So you cannot edit a blue box, you can edit the white boxes. There's options to specify a constant temperature loss in the production well here, or you can calculate it using a Ramey model implementation to calculate it internally. You can specify the decline of your temperature decline of your resource as a percentage per year, and specify a maximum temperature decline that's allowed before there's a reservoir replacement. And then we can get into defining our pumping parameters. So a key one is your flow rate in your production well, and then pump efficiencies, diameters, casing sizes, and the like to figure out your pump work, which is then combined with your output to get your gross output, and then your net plant output. Power block is another one that's not a key page for you to focus on if you're using the GETEM model. The GETEM model is chosen by default. There's also options for more generic power block models where other inputs come into play, but the GETEM model, you don't really need to use this page. Grid limits, this is just setting, if you want to set a point of maximum outputs per time step that can be power that can be sent to the grid per time step. So if you want to set an interconnection limit, or if you want to specify how many megawatts are curtailed at each time step, you can set a schedule like that. Next, we get into cost. So here, there's also calculations and percentages the user has to provide on confirmation wells, success ratios, ratio of injection to production wells. New to this version of SAM, we have the option to change your producer price index year. This affects PPI indices for a variety of different materials such as steel, heat exchangers, piping, that kind of thing that affects the power plant costs, which we'll get to later. You can define your exploration costs with cost multipliers, how many wells you have, and that to figure out your exploration costs. I mentioned the drilling costs. So for each combination of well type, we have vertical open hole and deviated liner, and well diameter, large and small. There's a base case, intermediate 1, intermediate 2, and ideal cost curves. And those are printed on this graph with a red dot showing for your resource depth that you defined on your geothermal resource, where you are on that cost curve. And that defines your production drilling cost, and then you can do the same for your injection drilling cost. Power plant costs, you can specify a dollars per kilowatt number for what the power plant cost is, or you can automatically calculate it. And that's where a lot of those that PPI index year comes into play. Inputs for dollars per foot and dollars per horsepower for your pumping costs. And all of these categories of costs also have an override where you can specify a total cost number rather than calculating. There's options to input indirect capital costs as a percentage of the direct costs. And all that sums up to a total installed cost, which is the key for your financial calculations. That's basically your CapEx number. Operating costs, there's options for a fixed dollar number per year, dollars per kilowatt per year, and cost by generation. Each of those can be defined as a single value that then has an escalation rate per year, or it can be defined on an annual schedule where you specify the numbers per year. With your CapEx and OpEx defined, you can move into your financial parameters. This is where you can set your lifetime, your project lifetime. So how long will the system be in operation? The inflation rate, the real discount rate, taxes, define what your taxes are, project term debt. So this is the debt for your system. Cost to acquire financing and a dollar number. A key one potentially for geothermal projects is this construction financing, where you can, in up to 5 loans, specify the percentage of installed costs associated with each of these loans and how many months prior to the beginning of operation those loans were granted, and then calculate interest that's added into the cash flow for those calculations. And there's also operating reserves that you can specify for your system. So after cost, we can move to revenue. There's 2 calculation modes here. You can specify, if you know your PPA price, you can specify it, or you can specify that you want to hit a particular IRR target in a given year with, and you can also specify a escalation in your PPA price as well. Incentives, this is where you would specify your ITC credits, PTC credits, as well as incentives for investment-based incentives, capacity-based incentives, or production-based incentives. Depreciation schedules you can define here. And electricity purchases are just here for parasitic loads, which are not a consideration for the GETEM model, so we don't have to worry about that right now. So once you've specified all your inputs, you can click Simulate. And you'll end up on this summary screen where we have a variety. First, you see a metric table of some key outputs, such as the LCOE, net present value, and your annual energy, as well as your monthly energy, some plots for energy, plots for NPV. Moving down through the different output options, there are data tables where you can see data for different intervals, annual data, hourly data, lifetime monthly data. So if you want to see the monthly power output from GETEM from each month for the entire 25 years of the system, we have it here. All of these tables can be sent to Excel or saved as a CSV or exported to the clipboard. You can make your own graphs using this tool, depending on the time series of your outputs. Detailed cash flows. So for each year of the system, you have your cash flow and can get a better idea of all the different cost components of your system. This can also be exported to Excel and sent to Excel with the equations included. So if you want to continue your analysis, you can send to Excel with equations, and it'll show how those are being calculated in the Excel workbook. Time series graphical outputs. So you can plot things against each other. And stacked graphs like this, you can look at different graphical options that way. Monthly profiles of various outputs for energy. Statistics such as the mean, min, and max for various outputs. Heat maps, you can generate from the outputs, and probability distribution functions for outputs as well. I'm a little ahead on time, so before we jump into more questions, I will show you the macros. So one important macro you could use for geothermal models is this geothermal plant efficiency optimizer. So for binary plants, which I showed you earlier, this macro will essentially optimize the plant efficiency for the LCOE of the binary plant. So if you have binary plant specified and you look at, it'll optimize this efficiency number to maximize your LCOE, to get the best LCOE number. And yeah, so that's how the macros work. These are written in LK, which is the language that's used in our external coding to add on to the analysis. Parametrics is located below the simulate button. You can add inputs. And specify how you want to vary those inputs. So I want to go from 2000 to 1500 by an increment of minus 100. And do something like that. Then it would automatically build 12 cases looping over all of those different scenarios. And then you could run those from this button and get outputs. If you want to see how that affected levelized cost of energy, you could see how those changes affected the LCOE. You could also vary them stochastically by a distribution in the stochastic tab next to the parametric button. So a normal, any type of distribution you can specify, and it'll use a Monte Carlo sampling method to vary this input over that range distribution. Yeah, with that, I think I'll open it up to questions and discussion. If Paul, do we have anything?
Thanks, Matt. Yeah, there's one question here, and folks, feel free to type in other questions if you have them. You can also raise your hand if you want to ask it by voice, and we'll unmute you. We have a question here. I think it's about the inputs on the geothermal resource page, the input table option there. The question is, are those assumed to be over the life of the system? And where's the system life defined?
Yes. So yeah, ideally you would want coverage because it's iterating over the how much time has passed in the calculations, which is the life of the system, and that is defined by this analysis period, which is how many years the system will be in operation. So yeah, there is a bit of a right now there is a bit of a calculation needed to go from that to seconds. Maybe this is I'm not familiar with the standards in the reservoir modeling format, but yeah, so ideally you'd want your table to include the whole lifetime of the system, which is defined on this financial parameters tab at the top. So 25 years the system will run.
All right, and then there's another question. Are there analogs to a few features from Excel GETEM? For example, endogenous O&M costs?
I'm not familiar enough with the GETEM model. I haven't made many updates to our SAM O&M, so I would say probably not at this point. Dao, do you want to chime in on that piece of the GETEM model, the O&M?
So in GETEM, you can specify. So yeah, you can specify your own O&M costs, and you can also use the default, right? But here in SAM, it's mostly like a ballpark sum. It's not like compartmentalized. Like you don't have those breakdowns, in SAM. I think that's the major difference. So in GETEM, you have, stuff like labor costs. You have, service costs, maintenance costs, costs for materials, insurance, and things like that. They are not really listed here like you have in the Excel GETEM model.
Right. So yeah, I would say on that, I would say right now these O&M costs are the way they are to kind of align with the rest of the SAM models and how they define O&M costs. Hopefully there'd be a way through one of these input options, whether it's a dollar amount, dollar per kilowatt, or a dollar per megawatt hour, to bring those more detailed operating costs into the SAM structure somehow, whether it's a single value with the escalation or in a table here. Then you can import annual numbers in. Ideally, you'd be able to fit those values in somehow, but if that ever becomes an issue, then yeah, you could definitely reach out and we could try to figure out a way to do that. I don't know. Yeah, right now we just don't have that level of granularity on the O&M costs in here.
And then the other related part of that question is on the results tab, with capital costs per kilowatt broken down by category. So, I mean, I think in general, the as Matt mentioned, the cost inputs in SAM, both for installation and operating costs, SAM doesn't have a detailed cost model. So if you've got an external cost model, the idea is you would roll up the cost from your detailed cost model into the higher level costs that SAM requires as input. And then for results, we show that the annual cash flow tab here that we're looking at now has, again, sort of high level costs, high level line items, so that I think the total installed cost is a single line item rather than having a detailed breakdown of the installed costs. We have a line item for operating cost that are specified in the 3 different cost units as input, but there's not more detail than that in SAM.
Correct. Yeah, for both the CapEx and the OpEx, those cost pages serve to get you total numbers. So either total CapEx and then OpEx in those 3 categories in a dollar number, and then yeah, that's what's presented in the cash flow.
Are there other questions?
I did fail to mention on the input pages and on outputs, but on any of these input pages that you see, there's the help button in this top right corner, and that will take you to the help page for those inputs and give you some more information about what those inputs are specifying and how they work. So this is part of our help documentation that hopefully will help people as they're starting out on their projects. And this will, yeah. So that's how the help system works.
And there's a question here about the financial models. Is the geothermal financial model the same as the models for the other technologies in SAM?
Yes. So as you can see, if we go to a photovoltaic case, we have the same power purchase agreement options. The PV might have a little bit because it also has the distributed side, but then the geothermal, right, has those 4 PPA options, merchant plan option, and then a simple fixed charge rate method of calculating the LCOE.
And I think one of the reasons that SAM was originally developed was to facilitate comparisons between technologies. So we do try to keep the financial models consistent across the different technologies. which is a partial explanation of why we keep the cost inputs at a relatively high level to make it a little bit easier to do that kind of comparison. And then following up on that, are the financial models described somewhere? And yes, there are descriptions of them in help, and there's some additional documentation on the SAM website.
Yeah, so there's a help page here for each of the financial models. And yeah, Paul, you covered that.
One more question. Should the alternative power blocks, monthly, hourly, not be taken as representative of the geothermal plants?
I haven't spent much time with these. I'd have to look through them more to know. I mean, it's taking the same like thermal input, I believe, but I'd have to study it more to give you a better answer on that. I've been focused primarily on the GETEM model.
How would the code to perform this simulation with PySAM look?
So we recommend for people, especially if you're new to PySAM, starting in the desktop tool and then on your case, so this untitled case here, you can click this drop down and go to the bottom here and generate code. And you see at the bottom of this list here for code languages, you have this PySAM JSON. This will create a file for PySAM to read all of your inputs that you've specified in this case. And that would at least make it easier to get started in PySAM and have all your inputs be correct, because PySAM isn't as clear as user interface in terms of you knowing what your values are for each input. So that's how we normally recommend people to start with PySAM. And that's how I would recommend you start your analysis for GETEM in PySAM. And then you could extend your analysis from there, change inputs from the commands in PySAM. There's some help documentation on that as well.
Yeah, I would recommend going to the PySAM documentation on readthedocs.io. It was recently updated, so there are instructions on how to get things set up, how to get inputs exported from SAM into PySAM, and then there's also detailed documentation of each of the compute modules there, so you can look at the inputs required for the geothermal model in the PySAM documentation. You could discuss maybe the default costs, where they come from and what they represent.
Yeah. So yeah, a lot of these cost calculations come directly from the GETEM Excel model. These drilling cost curves, which a lot of work went into putting them in SAM, the modeling came from the well cost simplified model developed by Sandia. I don't know a lot about that model personally. Dio, is there anything context you want to add to that well cost simplified? And then I know the different cases for each of these different combinations comes from a piece of the GeoVision study, which maybe people in geothermal are more familiar with.
Yeah, so the well cost simplified model was developed by Sandia, spearheaded by Thomas Lowry in Sandia, and basically it takes in inputs of the rate of penetration and the bit life, and then outputs tries to use that information. Well, and also the well attributes, the casing type, the casing size, the depth of the well, things like that to determine to generate a cost curve that helps you to determine to get an approximate value of where you are on that particular cost curve. So it's divided into the baseline, the intermediate 1, intermediate 2, and the ideal based off of the GeoVision study that looks at the various combinations of reference and intermediate cases to develop projections for future geothermal deployment.
Right. Not seeing any additional questions.
Okay. Yeah, and just another reminder, this is being recorded. The recording will be posted in the next couple days following the conclusion